Hey, stat students, welcome to chapter 7. Congratulations. You are getting to the heart of statistics and inference, which is how we make conclusions using statistics. So to start us off, we actually have to look at two distinct ways we collect data. We either collect data about a population or off of a sample. And so that's what our goal is for today, which is distinguish between those two things, a sample and a population. So we're going to use this example here where we have this fifth period class and they took the chapter 6 test. And there were only 4 people who took the chapter 6 test. This is just a hypothetical. It's small numbers so that we can manage it. Okay, their scores were 60, 70, 80, and 90. So what are we talking about here when I talk about the population? Well, the entire class, that's the 4 students, that would be our population. So if I'm going to create a population distribution, which you see here, I'm going to plot out all the scores of everybody in that population, right? There's one student with a 60, one student with a 70, 80, and then that's that one individual with a score of 90. That's what you'll see in a population distribution, all the individual outcomes plotted. All right. So if I took a sample of 2 scores, let's just take a random sample here and say that sample came out with the two students that had a 60 and a 70. If I was to take the average of that, right? How do we calculate the average? You add and then divide by how many. So I would take that 60 and that 70, add it up and divide by 2 because that's how many numbers I have, right? And that's where that 65 comes from, right? Notice the symbol that we used. It's an X bar. That is now a symbol that you have to distinguish between. You need to understand that if you see X bar, it's talking about the sample mean, not the population. So there's your first introduction to a different symbol, X bar, sample mean. All right. Now the next question here, number 3, has us looking at every single possible sample. That's all the different combinations that you could have. And because there's only 4 students, it makes it a lot easier to calculate that. So I could have one sample with a 60 and a 70, a 60, 80, 60, 90, 70, 80, 70, 90, 80, and 90. Those are all the different combinations you can have in this class of 4. All right. And then each of those has their own average, right? So this first group is an average of 65, second group average. You see that. And it's all delineated by the X bars. Well, if I take all of those X bars, those sample averages, and I plot those out, that's when you have yourself a sampling distribution. Keyword sampling. And notice that this class is all the averages of every single possible sample of size 2. So if I'm looking at this dot here at 85, it's not an individual that has a score of 85. It's a sample of 2 with a mean of 85. Very distinct difference, right? A sampling distribution would be the outcomes of all my samples. A population distribution would have every individual in there, right? That is an individual. And a sampling distribution, it would have the outcomes of my samples. All right. So if I were to take all of these sample averages, right, add up the 65, the 70, the 75, 75, 80, 80, 85, then divide by how many we have, 1, 2, 3, 4, 5, 6, I would get 75 is my answer. So if I notice my sampling distribution, the way it played out was that it actually has the same average as the population would have. Okay, when that happens, class, if you do the sampling distribution in a good way, you would now have what's called an unbiased estimator, right? Because my sampling distribution average, which is which came out to the 75, ended up being the exact same as my population average. So there you have it, okay? That would make this an unbiased estimator. And that's a new term, and we're going to have to build on that a little bit later, but that's where that comes from. So we've now seen two things, right? What a population distribution tells us, right? We've got the plots of all of our individuals. What this symbol X bar looks like, it's the sample mean. What a sampling distribution looks like and what those dots represent. It's the outcomes of your samples. And then if in my sampling distribution, the center lines up with the population center, you're dealing with an unbiased estimator, which is what we are shooting for. The last thing to note here that I didn't mention before is notice the symbol that's used for the population mean. That's the one that we were used to when we were doing our normal distributions. That's the mu. So you now have to distinguish between this symbol for a population mean and that X bar for a sample mean. Head to the next page for further explanations of sampling and population distributions.